This equation really represents the fact that I think aging is a loss of information in the same way that when you Xerox something 1,000 times, you'll lose that information, or you try to copy a cassette tape, or even if you send information across the internet, some of it will get lost. That's what I think is aging. And there are two types of information in the body. There is the genetic information, which is digital, A, T, C, G, the chemical letters of DNA. But there's this other part of the information in the body that's just as important. It's essential, in fact, and that's the systems that control which genes are switched on and off, in what cell, at what time, in response to what we eat, etc. And it turns out that 80% of our future longevity and health is controlled by this second part, the epigenetic information, the control systems. I liken the DNA to the music that's on a DVD or a compact disc. For the younger people, we used to use these things.
I recall.
Yeah. And then the epigenome is the reader that says, okay, in this cell, we need to play that set of songs. And in this other cell, we have to play a different set of songs. But over time, aging is the equivalent of scratching the CD and the DVD so that you're not playing the right songs. And cells, when they don't hear the right songs, they get messed up and they don't function well. And that is what I'm saying is the main driver of aging. And these other hallmarks are largely manifestations of that process.
Can we go a little deeper into what these scratches are? Is it the way that the DNA are packed into a cell? Is it the way that they're spaced? What are the scratches that you're referring to?
So DNA is 6 foot long. So if you join your chromosomes together, you get about 6 foot per cell. So there's enough to go to the moon and back 8 times in your body. And it has to be wrapped up to exist inside us. But it's not just wrapped up willy-nilly. It's not just a bundle of string. It's wrapped up very carefully in ways that dictates which genes are switched on and off. And when we're developing in the embryo, the cell marks the DNA with chemicals that says, okay, this gene is for a nerve cell. You cell will stay a nerve cell for the next 100 years, if you're lucky. Don't turn into a skin cell. That would be bad. And those chemicals, there are many different types of chemicals, but one's called methylation. Those little methyls will mark which songs get played for the rest of your life. And there are other marks that change daily. But in toto, what we're saying is that the body controls the genome through the ability to mark the DNA and then compact some parts of it, silence those genes, don't read those genes, and open others, keep others open that should stay open.